Hi guys, could you hear me?
Yes, ma'am.
Okay. And hope my Microsoft whiteboard is visible.
Hello, food for the body cuts.
Sorry?
No, ma'am, it is visible.
Yeah, okay. So let's start the session. What was the question? Okay, we were saying move zeros, right? In the last session.
Yeah.
Yeah, okay. Let's continue to see the advanced version of it, the optimal solution. So what we saw in the last classes, there is an array which will have some zeros in it, and we will have to move the zeros to end of the array, and the remaining all should be in the relative order, in the same order. And what we did is, um, we first created a temporary array, and there we copied only the non-zero element. Then we added, after we copy completely to the new array, we replace the remaining position with 0. We place 0 in the remaining position. To understand how many zeros are there, we also had a count. Okay. Now the other option is a 2-point swapper. Okay, I guess it's visible now. Okay. So we can use a single pointer to track. So here we need 2 pointer, so that we need not have a new array. Okay. So we can use 1 pointer to track of non-zero element. Okay. And as we scan through the array, every time we find a non-zero element, we swap it into the uh, position where we found the 0. Okay. So what we are doing is, let me draw an array. Okay. Here we have an array. Okay. So we have 2 pointers. Okay. Let me put pointer in the like arrow mark. Guys, is it visible, or you want me to increase the? It's visible, right?
It's visible.
Okay. Okay. Now what we are going, let's assume we have 0, 3, 4, 2, 0, 1. Okay. And this pointer the first pointer will keep track of zeros. Okay. Keep track of zero's position. It's not exactly 0, but the position of the 0. Okay. And the other pointer scan. So this pointer will scan through all the elements. Okay. And another pointer remembers where the next non-zero should go. Okay, so one is to keep track of all the non-zero, another is to scan. Okay, so let's see. Let me put it as a variable I and insert position. So this particular pointer will scan every element. It will go through every element. Okay, um, and when it goes through, it knows where what is zero and what is non-zero element, and this particular pointer interposition will uh, track of, so that is nothing but the zero position. Okay, it will track of zeros position, so it will have the index. Okay, it will have the index of zeros, so that you can place the non-zero element here. Okay, you can remove the zero and you can place your non-zero element here. That is the whole idea. Okay, so let's see the algorithm. Okay, so let me write the steps of algorithm. One is we have a one pointer, okay, insert position, which will know the zeroth position index, okay. So insert position is equal to 0. Initially it is set to 0 to track the next non-zero element, okay. And then second is we have index I, and it will go from 0 to n minus 1. We are nothing but we are scanning the array. We are traversing the array, okay, one after another element. And that when num of I. So I is nothing but index, right? I is nothing but index. So array of that particular index is not equal to 0. We then, what we do? We swap. Okay, when it is not equal to 0, we swap. Swap what? We will swap this with this. Okay, so we swap non-zero with 0. We will swap the positions. So we are placing this element here and we are placing this element here. Okay, so what we will do? We will swap num of I with num of, here we have insert, insert position. Okay, so one array is to keep track of every element, and it will stop when it sees a non-zero element. Okay, that is num of I, that is I. Another will keep track of all the zero element. Okay, so whenever we find one non-zero and another zero, we swap them. Okay, so that the positions are changed. The non-zero is placed into the zero. Okay, and after all, after the loop, we do this in a loop so that we scan through all the element. Okay, after the loop, all non-zeros are at the front in the original order and all the zeros are at the end. Okay, so the main idea is have two pointer, one is for zero, another is for non-zero, and swap. Okay, two pointer and swap is what you have to remember. Let's see the coding implementation. Oh, this is a move zero, what we have seen last week, which is not the efficient one. And zero is optimal. So let me put it as TP for two pointer. Let me first check if my code is working. Okay, so we got the right answer. Okay. Okay, let me go through it. We read through, we got the input. Okay, now our function is called. Okay, it is called from the memory. Okay. So initially we have one pointer which is in insert position. Okay, and here initially we are giving a value 0, 0th index. Okay, then we have a for loop. Here we are traversing from 0 to n minus 1. That is to traverse all the elements in the array. And then we are checking. So all the element we are checking one after another if it is 0 or not. Okay. So first element is 0 actually in the array. The first element is 0. Here you see. And this will become false. If it becomes, sorry, yeah, it will become false. Okay. Then it will go back to the for loop. Okay. Only when it is becomes true, the line number 9, you will see the line number 11 and 13 are executed. Otherwise, it is returned back. The control is returned back. Now we see the next element 1. And here the condition is true because 1 is not equal to 0. Now what we are doing, the insert position was initially 0, set to 0, right? So that value is taken. Okay. So here you see the current position, the value of I for this particular loop iteration is 1, okay, which is index 1, first index. The value is also 1, okay. The value is also 1, 1 is picked. And the insert position here, the value is 0. Whatever we have initialized, after that it is not changed so far. So we are gonna take the 0th index of the array. The value is also 0 here, okay. And what we are doing, we are taking I and we are placing into insert position. We are taking insert position and we are placing it into I. Okay. We are swapping it. So this is an important line. Apart from that, you know how to do for and if. Okay. And then we are incrementing the insert position. Okay. Now the insert position is incremented to 1, index 1. Initially it was 0. Now after it got swapped, it is incremented to 1. Okay. So now it will remain 1 until next time we change it. So yeah, so for this for loop, the I is incremented to 2. And now we are going to get the second element of the array, which is actually 0. So it is again true. If it is, sorry, now this condition will become false. So we are returning the control back to the for loop. Next is third element. So the third element value is 3. And 3 is not equal to 0. Yeah, it's true. So we can now good for swapping. Okay. So last time, where did we see 0? The 0 was moved to position 1, right? After the last iteration. So now let's see. So here we are going to take the third position, which is also the value is 3. So we have taken 3. And last time the insert position was updated to 1. So first position is nothing but 0. Okay. 0 is taken and we are swapping it. We are placing it in a different position. The index 3 and 1 are swapped. Okay. Now again we are incrementing the value to value of the insert position. Now you see the array got changed. The array initially was 0. What was the initial one? 0, 1, 0, 3. Now we have 1, 3. The 1 and 3 got moved to the first two position and the 0 is moved to the next two position. Okay. So now let's again check the fourth position, which is value 12. And it is also true. Now we will be swapping it 12 and the last time the insert position was taking care of this second position. It got incremented to 2. The second position is 0. So the second position and the 2 are interchanged, swapped. Okay. And now we have reached end of this for loop. The for loop has traversed all the elements. So we are exiting this particular for loop. Okay. And after we exit the for loop, there is nothing else in the function to run, and it returned the value back. So you see the value is 1, 3, 12, and 0, 0. Anybody has any doubt in how it got swapped, or how are we taking care of tracking both the element?
I'm using the link what you have
No.
shared, you will get 1,000 coins.
We are clear, right?
And it's
Or you
very
want me to
good.
explain in a different way? We are good. Okay, cool. So sorry, where is that? Let me submit the solution into lead code. Okay. Let me go back to. I'm just copy pasting my function, okay, into the lead code. Move 0. So the question number is 283, but if you just simply search move zeros, you will get the question. Okay. So let's go. Python is do not return anything, modify in place instead. Okay. We shouldn't print anything. We have to only return. So okay, let me submit this, run this. Indentation issue. Okay. Okay. So here both the test case, this one and this one. Here only one value is there. Both are completed. Okay. Let me submit this. Okay. Let's go to the next question. One five. Okay. So the next question is find kth largest element in an array. So what does kth means? Maybe I can tell first largest element in an array, second largest element in an array. Okay. Usually it was first and second. Later the interviewer started asking third, fifth, all those things. So instead of like having first, second, let's solve it for kth. Whatever value they are asking in the input, that so here k is equal to 2. Here we have to find the second largest element in the array. Can someone tell what is the second largest element in the array? What is the first largest element in this array? In this particular
6.
array nums. Okay, what is the
6,
second? After 6,
5.
what is the next
5.
largest? Yeah. So here we have fourth largest index. So anybody has any idea, rough idea in the mind, how do we go about this problem? What can be done to find the largest element?
We need to compare with the other value in the array. Like if you
Okay.
think the array of 3 is the largest number, then we need to compare with the array of 3 with array of 2. Like that we need to compare with each and every value, and we need to put store that value in an we need to store that value so that we can print that largest
Okay.
number.
I was thinking immediately after seeing this, can't we just sort the array? Then I can easily first the second or third largest element. Can't I do that?
Yeah.
I
Yeah, we
can do
can
that.
do.
If I
Huh.
sort and use the
Okay.
net.
Time complexity only.
No, the initial issue is not with the time complexity. Here you see in this array, there are duplicates. Okay. We have 2 twos and 3 2 threes. Okay. So if after sorting, so how it will look 1, 2, 2, then 3. The fourth position will be 3. Okay, but the output is actually 4. If there are multiple duplicates, we cannot directly go to that particular index and pick that up, right? So that is why, to make you sure, I mean, make you understand that there are duplicates, the second input was particularly given with lots of duplicate in it. Okay, so there can be duplicate. If the questionnaire interviewer is asking it is without duplicate, and then the solution will be different. Okay, so let's see with the duplicate only, because that would work for without duplicate also. Okay. Um, so they clearly mention not the kth distinct element. If you sort it and if you take the fourth position and give them, they will not accept it as a um, fourth largest element. They wanted the real largest element. There might be multiple three, but still they are considered as the third largest element only. Okay, if they have one, two, three, three is only the third largest element, even though it has 10 threes. What is the next value? 4. 4 is the fourth largest element. Okay, and they were actually asking, can you solve without sorting? So that is okay, we can solve with or without sorting. So first, I got a answer that we have to compare, right? We can do that. Let's see how we can do that. So that was a brute force approach, like compare each element with every other element. Okay, and check if it's the largest element. Okay, based on the largest output what we got, again we can compare. Okay, we have to go towards we see the particular largest element. Let me go back to give me a moment, guys. Okay. So first step is pick an element in an array. Okay, we have to pick element and then later second is we have to compare. Okay. So let's take an array. Okay, simple array 4, 7, and 2. Okay. So what we do first, we take 4. Okay, and we compare it with we compare it with 7. Okay, we compare 4 and 7. Which one is larger? 7. So we take 7 as the largest. Okay, then again we compare the 7 with 2. Okay, and we know that 7th is the largest. So this is a way of finding the first largest element. Okay, now let's see. Let me show in the Tony. Sorry, this is the pseudocode. Okay. So let me first show the pseudocode. Okay. So we have a for loop which will traverse all the elements from 0 to n minus 1. So we are traversing each element and then later we are checking if it is the largest element. Okay. So we are taking 4 and 7 and then we are seeing if it is the largest element. If it is, and we have a condition, we have a Boolean value. We are setting the flag either true or false. Okay. We are setting it. And again, we have another for loop. Okay. So this is I. So this is J. So if you have to compare two elements in an array, definitely you have to have another for loop. Okay. Because you compare 4 against 7 and also you compare 4 against 2. And then later you compare 7 against 2. So this is how we have seen, right? How do you compare all the possible pair? You have to pick 4. For the first for loop will take care of that. Okay. The second for loop is to compare 4 with 7, 4 with 2. Similarly, the first for loop again will go back to 7. Okay. Move forward to 7. And then the second for loop will take care of comparing it against 2. And if you have another element, it will go there also. If you have one more element, it will go there also. It will compare against all the remaining element available in the array. Okay. So we have two for loop, which is to compare. Okay. And then what we are doing, we are comparing n of I with n of j. So that's how we know greater or less than. Okay, that's how we know whether 4 and 7, which one is the largest, whether 4 is large or not. Okay, and let me show the Python code. Okay, the largest element. So this solution is just for the largest element. We do not know, we do not have it arrived to the kth largest element. Okay, here this particular function is to just find the only one, the first largest element in the array. Okay, first we will go through it. Okay. What is the problem? Largest element 4712.
Is it max of
If
array? Max
sorry,
the
yeah, kind of max of array. Yeah. If you have to do max of array, you can go by the sorting way also, because when you sort, either it is having a duplicate or not, the last index n minus 1 will be the largest element. That we are very clear, right? So first I'll show the largest element, okay, with the same approach, with this approach, comparing, okay, because the other way, no, the sorting way, you sort and get the n minus 1, which is the largest, will not work for the second or third largest element. So first we will see without giving any kth value how this is happening. Okay, we are going into the function. There is a problem with the indentation. Give me a minute, guys. Okay, the output is given. Okay, let's go back. So initially we are setting is largest. This is a variable we are setting into true. Okay, later we will disable it to false. Now we got J. So initially we are comparing a 0 against 0. And a 0 and first index we are comparing. Okay, we found the first index is the largest element. Okay, so the if condition becomes true, so it will go and execute line number 11 and 12. So the previous, whatever the for 4 we have set the is largest equal to true. Okay, that we are ignoring it. We are making it false. Okay, and then we are telling is largest is false, and we are going back to the for loop. We are going to the next element. Okay, next element is nothing but, so the first element, when what's happening is the first element is compared with the remaining all element in the array, which means 0 versus 1, 0 versus 2, 0 versus 3. But in 0 versus 1 only, we found the first element, the 0th element is small. So we need not compare with 0 versus 3, 0 versus 4 and all. We can ignore that. We can cut that for loop and we can move to the first element. Is it clear, guys, what I am trying to say? Or is it confusing?
Yeah.
Clear,
Yeah.
right? Okay. So now we understood the first element is anyway smaller compared to the zero. The 0th element is smaller compared to first element. So we are not comparing, moving ahead with the 0th element at all. We are ignoring it. Okay. Now we are picking up the first element. We are going and comparing it against. Okay, here there is a problem. I have to change the second for loop. So when I have to compare 0, I have to j from, let me stop this. So instead of comparing j from 0 to n, what I have to compare is I plus 1 to n minus 1. So let me put like this. J in range of starting from I plus 1 to n. Okay. Let me save this. Okay. So the first fourth element we are comparing directly with the seventh value, first element. Okay. 7 value 7. 4 is compared with value 7. So we found the 4 is small. We are ignoring it. We are going to the next element, which is 7. And then the 7 is now compared with the third element, which is 2. Okay. The value is 2 in the third element. So we are comparing 2 with 7. We found that 7 is still the largest one. Okay. So we have to go ahead. We have to compare 7 with the remaining all element. So we are comparing it against with the 1, okay, the last element 1. And we found that 7 is the largest when I compare with the remaining all element. Now I need not go and compare 2 with the remaining element, 1 with the remaining element, because I know 7 is the largest when I compared with all the remaining element. So I can like exit the program. I need not go ahead with the 2, 1 comparing their pair. Okay. I need not do that. So I'm exiting, returning the value 7. Okay. You want to try with different input? Any doubt here?
I will it to work for duplicates as well, like
Sorry.
477. Duplicates as well. 477.
So here the problem is only with the largest element. Okay. Now we will go ahead and we will see about the duplicates. Even if it is a duplicate, right? This comparison will take care of it, because when you compare 7 against 7, so we will go to the, so let's see how do we go about the duplicate. But now what is the problem with this approach? Ignore duplicate, okay? Even with consider the your input array is not having duplicate and you're asked to find the first largest element. What is the problem with this approach?
Time complexities.
Okay, what is the time complexity here? What is the time complexity here?
And square.
O and 2.
N square. Yeah, O
Oh,
of
and
n
square.
square. So the time complexity for one for loop is O of n. When the for loop, when you have a nested for loop, then it is O of n square. Okay. Okay, I have one question. Okay. What is the time complexity of nested for loop? Okay. And what is the time complexity of two for loop in the code, but they are not nested?
O of N1.
Sorry.
N1. Only one.
N1, n power 1.
Yeah.
Okay. Okay, let me explain. Any other answer?
O of n.
Okay. So one is like for loop. Inside it, you have another for loop. We did a calculation that particular day where we found that when you calculate the time for I plus plus all those iteration, all the calculations computation you are doing, after that we found it is O of n, right? And for I we are calling j. For every I you will be calling multiple j. Okay, so here when you do the multiplication for every I, you are doing every j, which means for every one element, you are doing n times n element, going through all the n elements, right? For example, you take the first element in the array, okay? But for j, what you do with the first element, you go through all the n elements in the array. And for the second element, again, you go through all the n elements in the array. And for the third element, again, you go through all the n elements, okay? So it is like 1 into n plus second element into n plus, so instead of making 2, let me put the next element, okay? It's not 2 into n, the second element, one more element, okay? And then for 3, so let's consider the array as 1 2 3 4 and 5, okay? And then for this element, again you will go through n plus, again you will go through n plus, again you will go through n. Okay, so it is nothing but n into n. For every n, you are gonna do n times. Correct. So that is why it is n into n, which is equal to n square.
Ma'am, can you explain again?
Okay.
This is for one for loop, right?
This is for two for loop. One for loop is simply O of n. We have already seen why it is O of n. We did I plus plus, all those iteration we did, and we calculated how it is O of n that one day. Okay. So let's not go into what is a time complexity of one for loop. One for loop is
Oh,
very clear, O of n. When it is nested for loop, which means for I and you have for j inside it, okay? And this j depends on I plus 1, 2, n minus 1 for 0 to n. Okay. So how do you do for first, for example, here the array is 1, 2, 3, 4, 5. Okay. And here, what do you do? Here again, you have the array 2, 3, 4, 5. Let's take one also, or 2, 3, 4, 5. Okay. So when you take one, you compare it, whatever operation you are doing. For one, you compare it. The one pair is 1 and 2. The second pair is 1 and 3. Third pair is 1 and 4. And fourth pair is 1 and 5. So how many times you have run for one particular iteration of this for loop? You are running 4 times this for loop. Correct?
Yes.
And then the second element, okay, one more element. For the second element, again you will be running 3 times. Again for the
Yes.
third element, you will be running 2 times. Again for the fourth element, how many times you will be running? 1 time.
One.
And fifth element you will not be running. When you add everything, 8, 9, 10.
Okay.
Okay, but
It is
actually
not like that O of n into O of n.
it is actually O of n into O of n. Okay. So here it will be a slight difference because you are comparing it. Consider you are comparing this particular array with every element. Okay. Then you will be doing for this one 5 times. And you are comparing this with all the elements. Okay. Then again 5 times. This particular element you are comparing with all. And this one you are comparing it against all. Okay. 5. And for this element you are comparing it again with all element, and for this particular element you are comparing with all the element in the array. So how many times it takes? 25.
25.
10, 20, 25. 25 is nothing but your array is n, which is 5, and you got answer 25, which is nothing but n square. Correct? 5 into 5 is 25, right?
Yes.
Sorry, my board is actually I'm writing here. Okay. uh, So yeah, for every element you are doing 5 times the operation, the inner for loop, okay? And it you totally you have did 25 times, and your n is 5, and this 25 is nothing but n
But
square.
but in this problem we are doing
Yeah, most of the
a
time we will be like ignoring the first few elements, but in general, some problem you will be doing in that way. Some problem you will be considering all the elements, okay? So let's not go into that. The few times we are removing few items. Let's not go with that. Let's go with the worst case. Time complexity is always worst case, right? So in this case, that's why when you find two array, which is one array inside the another, okay, you calculate O of n square. You
okay.
tell O of n square, okay. But consider you have another situation where you have for loop I, okay, for loop j, okay. This particular for loop does something, and this particular for loop does something. This j is not dependent on I at all, okay. They separately execute after this particular for loop is completely completed altogether. Then you come to this particular line, okay. Until then you are not coming to this for loop at all. So here in this case, what is the time complexity?
O of n plus O of n.
Correct. So this is the answer I was expecting. O of n plus O of n. Okay. Here you are doing n operation. Again here you are doing n operation, which is nothing but O of 2n.
Okay.
Correct? N plus n is
Yes.
2n. Okay. Um,
I mean, which
hmm.
kind for solving which kind of problems we use this kind of thing for two for loops?
So every solution can have two for loop, but that is a not optimal approach. Like you're comparing one element against the other. Here we have taken two for loop so that we take all the possible pair in the array. Correct? So
Okay.
all the possible pair is nothing but when you have an array. Let's not think about the value. Let's talk about only the index 0, 1, 2, 3 and 4, okay. And here I want to compare 0 with 1, 0 with 2, 0 with 3, 0 with 4, then 1 with 0, which is already covered here, okay, ignore that. 1 with 1, which is also not, sometimes it might need, okay, 1 with 2, 1 with 3 and 1 with 4. So you want all the possible pair. In that case you have to go for the nested for loop, okay. If you're not remembering the optimal solution, If you feel all the possible pair has to be looked into, then you can directly go in with a for loop. Okay. The only thing is, one mistake I did previously was here the range will start from 0 to n, and here if again it start with 0 to n, no, the unnecessary pair which we already compared also will come into the picture. So it will always be I plus 1, the next value of I till n. Okay. And if the I is 2, the comparison will start with the third element. You compare 2 with the third and 2 with the fourth and 2 with the fifth element. Okay. So, okay, the main question I wanted to, the main question was what is the time difference, time complexity difference between the nested for loop and two independent for loop? So it is clear, right? The nested for loop is O of n square and the independent for loop is O of 2n, which can also be called as O of n. So some people consider it as O of 1. Some people wanted a precise O of 2n. Okay. So you can, if in that case, you can, in an interview, you can tell, so since we have a two different for loop, which is not dependent on each other, the time complexity of O of 2n, which I usually consider as O of n. You can tell in that way. If they do not want to consider as O of n, that's fine. We can like always call it O of 2n, but usually it is O of n, okay? Okay, so what we saw is in the Tony, we saw what is the first largest element in an array, okay? Now let's go to the optimal approach. So before directly jumping into kth largest element, I want to first explain first largest element and second largest element. Then we will go to the kth largest element. Okay. Let me. Because kth largest element, actually we do quick select. Before going to quick select, I wanted to make sure you understand the remaining, or we can directly see the kth largest element. If you're not comfortable, you feel like too much thing is involved here, we can go step by step as for first, second, then the kth. Okay. Kth largest optimal approach. So let me go through the kth largest element itself directly. Okay. If you feel any, if you feel it's not very clear, we can then go step by step. I just wanted to see if you can understand, we can avoid seeing all the first and second. Because if you understand kth, in the place of k, you can place it 1, you can place 2. If they ask second largest element, if they ask fourth, you can place 4. You need not learn first and second and all. Okay. So let me go through it. Okay. So consider you have an array 0, 1, 6, 8, 9, 7, 4. How many elements we have? 1, 2, 3, 4, 5, 6, 7, 8. 8 elements. Okay. So the main idea here is pick a pivot. Pivot is you have to choose one particular element. Okay. The pivot will always be the first element or the last element or middle element. Okay. 1 minute. Okay. So first we have to pick a pivot, then we have to do partition. Okay. So the partition is based on the pivot. You can, as I said, you can take first or last or the middle. Okay. Here we focus on one side of an array. Okay. Let's see an example. So when you pick a pivot, consider you are taking the last element, okay, and you see you just traverse each element, okay. You traverse to you traverse through the array 0, 1, 6, 8. You traverse through all the element. When you find, so this is a pivot, right? So pivot, I place it here. When you find any element which is lesser than 3, okay, you place it on the left. When you, again, you are going through 1, okay. When you find an element which is greater than 3, you place it here, okay. And 8, you place it here. 9, you place it here. 7, you place it here. 4, you place it here, okay. And so you have to see whether the pivot has reached the correct position. Actually, here you see the pivot has reached the correct position 0, 1, 3. These three are in the correct position, right? So if at all I have to sort an array, okay, consider I'm sorting an array, sorting this array 0, 1, 6, 8, 9, 7, 4, 3. So this is my array. Index is 0, 1, 2, 3, 4, 5, 6, 7. If I'm sorting this array, how it will look after sorting? The least possible value is 0. Okay, I place it here. Then 1. Okay. Then 3. I don't find 2 at all. So 3. Then I have 4. There is no 5. Then 6. Then 7, 8, 9. And this is how the array will look after sorting, right? This is how the array will look after sorting. Okay. So here in the algorithm, what I'm following is I will pick a pivot in the original array. So the pivot can be the first element or the last element or the middle element. Okay. I'm going with the last element. Here I'm taking 3, and what I'm doing, I'm comparing 3 with all the element. I'm traversing all the element in an array, okay? And if it is smaller, I put it to the left. If it is larger, I put it to the right, okay? 0, 1 is going to the left, 3 will be there. The remaining all will go to the right, right? In the same order, like 6, 8, 9, 7, 4. So if you see, this first three elements are in the right order. After sorting whatever I would see, I'm seeing it now. Okay. The remaining all is not in the right order. The right side is not in the right order. Okay. So now what I'll do, I'll again, the pivot will change. So for this pivot, the last element, I have completed the placing the array. Again, I will choose this element. Okay. If I'm choosing last element as the pivot, I will keep going with the last element. Okay. Now 4 is the last element. Okay. This left side is actually ignored. Okay. Don't worry about the left side 0, 1, 3 because they are already sorted. Now I will take 4. Okay. 4 I will place here. Okay. Now if anything smaller than 4, I will place it here. Anything larger than 4, I will place it here. Okay. Then what is there? 6, 8, 9, 7 is got placed. Okay. The remaining are there. 0, 1, 3 remaining are there. So now you see the first 4 element are in the right position. Again, I'll go to the last element, which is my pivot. So what I'll do, so ignore this 0, 1, 3, 4. Don't worry about that, okay? Because I'm going through the second half of the pivot. So this is the pivot 4, and this is the first half, and this is the second half. Now 7, okay? 7, I will, whatever is lesser than 7, I will place it on the left. Greater than 7, I will place it on the right, okay? Now you see, we have reached when you compare this and this, we have reached the right, but we might not do while sorting, while doing this operation, we might not know sometime that we have reached. So what I'll do, so this is the left side I will keep it intact. Okay, I'll not worry about the left side. Now I'll go with the right side. I will take the pivot, which is the last element, and only one element is there in the right side. So I will take and I'll place it on the left side because it is the lowest value compared to 9. Is it clear? Do we have any confusion here?
Yeah, yeah.
Clear so far?
Yeah.
Can you explain again? I lost it.
Okay. So can we continue this tomorrow? Because anyway, we have reached end of the session. So tomorrow we can go through it. I'll explain what is the idea, algorithm behind it. If we learn this kth, right? Kth, it can be largest also, it can be smallest also. Okay, you can answer the first largest, second largest, or first smaller, second smaller, or fourth largest, or fourth smallest. Whatever question they ask, if you learn this particular program and algorithm, if you mug up this, if you know this by heart, you can solve any such question. Okay, in the lead code, yeah, there are multiple questions: first, second, first smaller, second largest. All those questions you can solve with this one particular approach. Okay, so tomorrow we can start again with the algorithm and how to find the pivot and place the array in the partition, and we will see the solution, guys. Thank you. Bye.
Thank you.
Mhm.